Hello all, I am Mahalakshmi working as an assistant professor in physics in Hindustan College of Engineering and Technology. Today we are going to discuss about shape memory alloys, their introduction, preparation, properties and applications. Shape memory alloy. A shape memory alloy is an alloy that remembers its original shape. It's also called a smart metal, memory alloy, muscle wire, smart alloy. An alloy after deformation returns to its pre-deformed shape when heated. An alloy that undergoes a large strain and capable of recovering the initial configuration at the end of deformation process spontaneously or by heating. Manufacturing of SMAs. SMAs are typically made by casting using vacuum arc melting or induction melting. These special techniques help to keep impurities in the alloy to a minimum and ensure the well mixing of the metals. The ingot is then hot rolled into longer sections and then drawn into wire. The way in which the alloys are trained depends on the properties wanted. The training dictates the shape that the alloy will remember when it is heated. The properties of SMAs are the yield strength is less than conventional steel, but some SMAs have a higher yield strength than plastic or aluminum. The yield stress for nickel titanium can reach 500 million pascals. They exhibit superelastic properties. High level of recoverable plastic strain can be induced. The maximum recoverable strain SMAs can hold without permanent damage is up to 8% for some alloys. The cost of the metals are high and therefore effective processing is required. They are implement SMAs into design. The processing is difficult and expensive to implement SMAs into design. There are two phases of SMAs. One is the austenite, the other is the martensite phase. Austenite is a high temperature, hard, firm, symmetric and inelastic state, whereas martensite is a low temperature state and it's soft, less symmetric and elastic. Austenite has simple FCC structure, whereas it has complex structure, and martensite has twinned and untwinned structures, whereas this austenite has thermal and mechanical deformation is large, and here in martensite heat or stress induced transformation is large. The shape memory effect figure shows the transformation from austenite to martensite upon heating and cooling. There exists twinned martensite and deformed martensite. De-twinned martensite state upon heating forms austenite. Austenite on cooling forms twinned martensite. Twinned martensite on loading forms de-twinned martensite. The SMA phase transformations versus temperature and load diagram is given. Austenite on cooling forms twinned martensite. Twinned martensite on loading forms deformed martensite. Deformed martensite upon heating forms austenite. The temperature transformations in austenite and martensite has a hysteresis shape. MS is a temperature at which austenite starts to transform to martensite upon cooling. MF represents the temperature at which transformation of austenite to martensite is complete upon cooling. AS represents the temperature at which martensite begins to transform to austenite upon heating, and AF represents the temperature at which transformation of martensite to austenite is complete upon heating. Advantages of SMAs are they have high strength, they are super elastic, they have fatigue resistance, high wear resistance, fabrication is easy and high power to weight ratio, lightweight, biocompatibility and shape memory property. Whereas the disadvantages of SMAs are their initial investment is high, sensitive fabrication is rendered and residual stress is high, lower maximum frequency of actuators and non-linear actuation force. There are two ways shape memory effect can be represented. One is one-way shape memory effect. When a shape memory alloy is in its cold state, the metal can be bent or stretched and will hold this shape until heated above the transition temperature. Upon heating, the shape changes to its original. When the metal cools again, it will remain in the hot shape until deformed again. In this case, cooling from higher temperature does not cause macroscopic shape change. two-way shape memory effect. The material remembers two shapes, one at high temperature and the other at low temperature. Figure shows the shape memory effect during both cooling and heating process. The metal can be trained to leave some reminders of the deformed low temperature condition in the high temperature phases. Above a certain temperature, metal loses the two-way memory effect. This is called amnesia. The figure shows some applications of SMAs in endodontic SMA tool. They are used in orthodontic arc wires. They are used in eyeglass frames, SMA dampers, and they are also used in the fields of medicine, optometry, engines, aerospace, robotics, automotive pipings, civil structures, water sprinklers, and textile industries. The figure shows the shape memory applications in road laying. Thank you all for your listening. Thanks again.